No vision of the future is complete without cars which run without petrol. And it no longer seems a far-fetched dream. You must have seen fuel cell operated cars on the road. Just plug in the charger, connect your car, and you are ready to get set and go. In fact, fuel cell can also be used to charge your phones. These fuel cell chargers contain hydrogen gas as one of the prime contents of fuel. What else does hydrogen do? Let's find out in today's episode. Hello and welcome to another fascinating episode of Chemistry. I am Devabrata Goswami and today we will be talking about hydrogen, the first element, the lightest and the most abundant gas in the universe. Yes, I am talking about hydrogen. Let's study about this amazing element today. In today's episode, we will first study about hydrogen and its position in the periodic table, its isotopes, then the preparation, properties and uses of dihydrogen will be covered. We will also be studying hydrides. In the end, we will have a look at important questions in exam decoded. To start with, let's study hydrogen and where it has been placed in the periodic table. Hydrogen is the chemical element with atomic number 1. And it is represented by the symbol H. Hydrogen has many unique characteristics compared to other elements. It is the lightest element known since it has an atomic mass of 1.0079. Do you know where hydrogen is placed in the modern periodic table? Yes, you do. But let me tell you, it was not an easy decision. Firstly, hydrogen resembles group 1 elements that are also called alkali metals. The electronic configuration of hydrogen is 1s1 and the general outer electronic configuration of alkali metals is ns1. Thus, hydrogen should belong to group 1. But hydrogen also resembles elements of group 17 called halogens. Halogens have a general outer electronic configuration of ns2np5. They can easily accept one electron to acquire the nearest noble gas configuration. Similar to halogens, hydrogen also needs just one electron to acquire the configuration of the nearest noble gas, that is helium. So hydrogen resembles elements of group 17 and should belong to group 17. In spite of the fact that hydrogen, to a certain extent, resembles both alkali metals and halogens, it differs from these as well and shows some unique properties. One of the properties is the size of the ion it forms. Size of H+ ion is approximately 1.5 times 10 to the power minus 3 picometer. This size is so small that it does not exist as an individual ion. Thus, it does not belong to either group 1 or group 17 and is rather placed separately. Well, that really means having an identity of your own, doesn't it? But hydrogen does have isotopes. Recall that isotopes are the atoms of the same element which have the same atomic number but different mass number. Hydrogen has 3 isotopes: protium, deuterium and tritium. Out of these, protium is the most common hydrogen isotope with a relative abundance of more than 99.98%. It contains one proton and no neutron. Thus, its mass number is 1. Recall that mass number is equal to the sum of number of protons and neutrons. The second isotope of hydrogen is deuterium. It has 1 proton and 1 neutron in its nucleus. Thus, its mass number is 2. And the third isotope of hydrogen is tritium. It has 1 proton and 2 neutrons. So its mass number is 3. So we can conclude that these isotopes differ from one another in respect of the number of neutrons and have the same number of protons. If you still have some doubts, you can also log on to www.topperlearning.com to make things more clear. Well, it's now time to take a break. During the break, why don't you try to answer this question? Which out of the 3 isotopes of hydrogen is radioactive? Keep thinking. I'll meet you with the answer on the other side of the break. Welcome back. I am Deobrato and you are watching Chemistry 11. Before the break, I had asked you which out of the 3 isotopes of hydrogen is radioactive. The answer is tritium. I hope you got that right. Till now, we learnt about hydrogen and its isotopes. Now, let us study its occurrence. In elemental form, hydrogen exists as a diatomic molecule, H2, and is called dihydrogen or hydrogen gas. And it is not just our planet that has an abundance of hydrogen. In fact, hydrogen is the principal element in the solar atmosphere. Giant planets like Jupiter consist mostly of hydrogen gas. Now let's see how we can prepare dihydrogen. Take 2 ml of dilute sulfuric acid in a conical flask. Add zinc granules to it. You can see bubbles of gas being formed. This is hydrogen gas. But an obvious question would be, why do we use dilute sulfuric acid only? What happens when we use concentrated sulfuric acid? Well, zinc reacts with concentrated sulfuric acid to form sulfur dioxide gas instead of dihydrogen. But another method of producing hydrogen gas is by reacting zinc with aqueous alkali. Let's understand this method. Take a solution of sodium hydroxide. Add zinc granules to it. Do you see the bubbles? That is hydrogen gas. Don't forget to write the balanced equation for the reactions in your exams. Let's now see how dihydrogen can be produced commercially by the action of steam on hydrocarbons. Reaction of steam on hydrocarbons at high temperature in presence of a catalyst yields hydrogen. For example, methane, when reacted with steam at a temperature of 1270 Kelvin in the presence of nickel catalyst, it forms a mixture of carbon monoxide and hydrogen gas. This mixture of carbon monoxide and hydrogen gas is called water gas. Do you know that this mixture is also called synthesis gas or syngas? This is because it is used in synthesis of methanol and large number of hydrocarbons. Besides hydrocarbons, syngas can also be produced from coal. This process of producing syngas from coal is called coal gasification. The production of hydrogen gas can be further increased by reacting carbon monoxide of syngas mixture with steam in presence of iron chromate as catalyst. This is called water gas shift reaction. Those were some of the methods of preparation of hydrogen. Now let's study its properties. The first property of dihydrogen is a colorless, odorless and a tasteless gas. Remember, when we added zinc granules to dilute sulfuric acid, the gas evolved was colorless. It is also highly combustible. Another property of hydrogen is that it is lighter than air. For instance, if we fill the first one with air and other one with hydrogen gas, we will see that the balloon filled with hydrogen rises more than the balloon filled with air. This shows that hydrogen is lighter than air. Now, let's get on to the chemical properties of hydrogen. Based on the various reactions studied by scientists, it is observed that hydrogen gas is not very reactive at room temperature. Well, nature has made everything safe. Imagine hydrogen reacting with things around it. But it doesn't. Let's find out why. This is because of high bond dissociation enthalpy of HH bond, which is about 435.9 kilojoules per mole. Let's now study some reactions of hydrogen. Hydrogen gas reacts with halogens to form the corresponding hydrogen halides. The most important reaction of hydrogen is that with oxygen, which gives us water. This reaction is highly exothermic and forms the basis of fuel cell construction. This is the reaction that powers the fuel cell driven cars, vehicles for public conveyance, submarines, and not to forget the mobile chargers, which we talked about in the beginning of the episode. So far, we learnt about dihydrogen and its properties. But what about its uses? Hydrogen plays a very vital role in welding and cutting. Atomic hydrogen and oxyhydrogen torches are commonly and widely used for welding and cutting. Dihydrogen is also used in preparation of hydrates, which are used as reducing agents in many organic reactions. But what are hydrates? Let's find out. Hydrogen under certain reaction conditions combines with almost all elements except noble gases to form binary compounds. These binary compounds of hydrogen with other elements are called hydrides. Depending upon the behavior and nature of bonding, hydrides can be categorized as ionic or saline hydrides, covalent or molecular hydrides, and finally metallic or interstitial hydrides. I am sure you are curious to know more about each one of them. Ionic or saline hydrides are the compounds of hydrogen with most of the S block elements which are highly electropositive. For example, lithium hydride. Lithium hydride is used to inflate lifeboats, jackets, and also signal balloons. Isn't that great to learn? But let's pause a bit here because we have a caller online.
Hello sir, I am Sveksha and I would like to know how many electrons does a hydride ion have?
That's a very good question. Let me answer. The atomic number of hydrogen is 1. It has 1 electron. Hydride ion has 2 electrons and is denoted by H-. So I hope you have got the answer. Next are covalent or molecular hydrides. They are binary compounds of hydrogen with elements of comparatively high electronegativity such as p-block elements. These covalent hydrides can be further classified as electron deficient, electron precise, and electron rich hydrides depending upon the relative number of electrons and bonds in their Lewis structure. Hydrides of group 13 are electron deficient since they do not have sufficient number of electrons to form normal covalent bonds. These hydrides act as Lewis acids. Electron precise hydrides have required number of electrons to write the conventional Lewis structure. Elements of group 14 like carbon, silicon, etc. form these types of hydrides. And the last type of covalent hydrides are electron-rich hydrides. As the name suggests, they have excess electrons than required to form normal covalent bonds. The excess electrons are present as lone pairs. Examples of this are hydrides of group 15, 16 and 17 such as ammonia, water, etc. And finally, let's discuss metallic hydrides. Metallic hydrides are compounds of hydrogen with many D and F block elements. Transition metals of group 3, 4, 5 of D block or chromium metal of group 6 and F block elements form metallic hydrides. The elements of group 6, 7, 8, 9, however, do not form hydrides, and this is sometimes referred to as hydrogen gap. The composition of these hydrides may not correspond to simple whole number ratio. Thus, they are also called non-stoichiometric hydrides. Examples are lanthanum hydride, zirconium hydride, vanadium hydride, etc. Let's now take a short break. Coming up next is the segment you are waiting for, Exam Decoded. Welcome back. You are watching Chemistry 11. But before we proceed, let's do a quick recap of what we have learned today. From this episode, we have learned that hydrogen belongs to neither group 1 nor group 17 but is placed separately in the modern periodic table. Protium, deuterium and tritium are the three isotopes of hydrogen. The binary compounds of hydrogen with other elements are called hydrides. Finally, depending upon the behavior and nature of bonding, hydrides can be categorized as ionic hydrides, covalent hydrides and metallic hydrides. Fasten your seat belts and put on your thinking caps because it's time for the segment you are waiting for, Exam Decoded. Welcome to Exam Decoded. Ready to face the rapid fire challenge? Let's begin. The rules are simple. I will ask you 5 questions and you have to answer each question in 5 seconds. Here comes the first question. Sum of protons, neutrons and electrons in the heaviest isotope of hydrogen is A 6, B 5, C 3, D 4. The correct answer is D 4. Well, it was simple, wasn't it? Here comes the second question. The mixture of carbon monoxide and hydrogen is called A. Natural gas, B. syngas, C. Producer gas, D. coal gas. Yes, you are right. The correct option is B. syngas. The next question. The radioactive isotope of hydrogen is protium. True or false? It's false, as the radioactive isotope of hydrogen is tritium. Great going. You have to pick the right one in the next question also. Hydrogen resembles A. Alkali metals, B. Noble gases, C. Alkaline earth metals, D. Transition metals. And the answer is A. Alkali metals. And here comes the last one. TiH 1.73 is an example of A. Ionic hydride, B. Covalent hydride, C. Metallic hydride, D. Polymeric hydride. The correct option is C. Metallic hydride. Let's tally your scores now. If you got 5 on 5, you are a high flyer. You are all set to rock in your exams. If you got between 3 or 4, then you are an achiever. And if you haven't scored above 2, then consider yourself still a learner. But don't worry, I have a remedy for your problems. Log on to our website www.topperlearning.com and find out more. The chapter Hydrogen and Hydrates comes under the unit Hydrogen, which has a weightage of 3 marks and is important from examination point of view. The questions asked from this topic can be very short answer type questions for 1 mark and short answer type questions for 2 or 3 marks. The questions covered from this topic can pertain to knowledge ability. I keep telling my students that knowledge alone is not enough. One should also know how to answer in a way that impresses the examiner. Let's do a trial question to demonstrate this. Explain what are electron deficient and electron rich hydrides, giving one example of each. This question can come in your exams for 2 marks. To get full marks, you must write electron deficient hydrides are those hydrides which do not have sufficient number of electrons to form normal covalent bonds. These hydrides act as Lewis acids. Example, diborane. Writing the correct definition of electron deficient hydrides along with example will fetch you 1 mark. As for the electron rich hydrides, they have excess electrons than required to form normal covalent bonds. The excess electrons are present as lone pairs. For example, ammonia. This statement along with correct example will fetch you your final 1 mark. I hope all your doubts and concepts are clear now. But if you need more help, do log on to www.topperlearning.com. I think today was really light teaching and learning, just like hydrogen. But I hope you must make it solid in your mind. That's all for today. It's time for me to say goodbye, but before leaving, there is some food for thought. Do you know that hydrogen is added to oils? This is done to harden the liquid oils and convert them into solid fats. This process is known as hydrogenation. Until next episode, stay light, think light, but study tight. Just like hydrogen. Because chemistry is all around you. All the best and keep thinking.